guys, it's Neel. I'm back for some more quarantine content. So, today we're going to be talking about Quicksort. I know we already talked about the merge sort, which is already a really fast algorithm, but Quicksort is really useful for two reasons. First, it's fast, right? It's fast, and as I'll tell you in more detail in another video, which will be coming after this, it's a bit random, so it can give you really slow, but there's a super tiny chance. So really most of the time, you're going to be getting a really fast performance that is really comparable with merge sort. And the second one that really stands it apart is that it doesn't take too much memory. So it has a low memory need. This is because it does a lot of its stuff in place. It's just swapping and some comparing, so you don't really need to save it into a different list like some other kinds of sorting. So let's look at how this algorithm works. So it's recursive, just like merge sort. So once you call Quicksort, because you want to be moderating which parts you're going to be doing this recursive part on, obviously you're going to need L, and then you're going to need your start and your end. So mind that the end, you might have to change it by the way that you've implemented it. In some ways, when you're actually indexing, it's going to be n-1. But if you program it yourself and you end up in that situation, then you'll see it. So once we have this Quicksort thing, then we need to check for the base case, and this is where the len of L. So the len of L equals 1. Right, then we can just terminate it. We just return, and we're all done. And this is the stopping point. So otherwise, what are we going to do? Well, what we're going to do is we're going to call up the partition method. Now, this is really the special sauce in the Quicksort algorithm. So, what do we do in partition? So let's take a closer look in the partition function. So obviously you need to list the start and the end, which you'll be keeping track of throughout it. Once you're done with your partition, you'll take your two smaller lists. So let me explain how this works. So I have this list, right? So let's say that this is the order and we want to sort it. So now we have to choose a pivot. So just for simplicity, we're going to just say that the pivot is this starting element. But in another video that I will be covering which starting pivots will really get you the high boost of performance and why does it give you that higher, better, faster Quicksort. So you take this and what you do is that you have two constants. There's I and then there's J. So both of them start here. What does I do? I would be what? The boundary between whatever is less than this pivot. So this is whatever is less than pivot. So it's basically like the boundary. Whatever is to the left of I is less than P or the pivot. And for j, this is just marking where the boundary between the unpartitioned and the partitioned is. So now, let's look at our very next step. So, we'll have to say goodbye to this part now so we can continue. And what is our next step? So, what we're going to do is we're going to compare this next one, 3, with our pivot. So, obviously, as we see, 3 is bigger than 2. So, what we do here is that we won't actually be changing our list at all or doing any of those swaps. Instead, what we'll do is that, you know how J and I, you know how they were here last time? So now, what we've gone and done is that we've partitioned this thing. So now J is just going to be moved here. And I is going to stay here. Because right now we have nothing that's less than 2. But it's going to work. And note that 2, it's just going to stay in the same place. We're going to swap that and move that at the end of the partition function when we found out what we need to do. So now, what are we going to do? Now, we're going to go and we're going to compare this to this. Now, obviously, this is less. So what are we going to do, right? Now, what we have to do is we have to swap it with the one that is just right of this I, because we want to get it just into the less part without moving any of the ones that are already there out of it. So what we're going to do is both of these are going to get swapped, and then because of this, we are going to shift I here, and then we're going to shift J here again. So we're going to keep on continuing this, right? And then what we're going to and then let's look at the end step where J is all the way at the end, right? So what if J is all the way at the end? What are we going to do to our list over here? So now what we have to do is we have to put the pivot in the right place, right? Because mind you, we haven't actually moved it yet, right? So let's say it turns out like this, right? You can check that yourself if you want to actually go through the whole thing. But just to speed things up, I'm going to say that, so let's say this is what we end up with, right? And then this is the split, this is the boundary line where I is. This is J, what J is, so we know that it's finished. So this is where the pivot needs to go. So what will we do? We're going to swap it with the one that's just right. So now what we get is a partitioned array. So our pivot's here, right? So now everything that is less to it, which is the 1, is on the right side of it. And everything else is just on the other side. So, mind you, it's not sorted, but it is partitioned, and this will help. Because now we just keep on doing this. So now what we have to do is this goes back into the recursive calls, and it calls Quicksort again with this array and this array, and you partition them. So then this ends because it's sorted, or really just have 1, but it's sorted, right? So we just return that. But now we have to partition this, right? So in this function, it will get to something again, right? Where the 3 is a partition, is the pivot, right? this is already partitioned because all of these are bigger than it. So now what we do is 3 stays here. We don't worry about the 3, and then we just do these 2, right? And then we pick this one, and then, oh no, we have to swap it over here. So now it's 4, and then 5. And now it gets to 4 and then 5, but then 5 was the pivot, so now we get to 4, and that is 1. So then, once everything is partitioned with this everything is partitioned, and we keep on using the partitioning method, now it is completely sorted. So, if you want to really get an optimal quicksort, then you're going to have to pay attention to your choose pivot function. Remember the one that we assumed was just going to be in the start? In my next video, which I will link down in the description, I will show you a really good and thorough analysis of the choose pivot and what kind of pivot will give you the optimal performance. Hi, I'm Neel Kumar, and that will be it for today. Thank you.